Okay, so in this session we'll be looking at polynomials, and typically this is important for the remainder theorem. And this remainder theorem is the algebraic remainder theorem. It basically is a very simple idea. We are here to find the factors of, so suppose there is a expression given to you as x cube plus, let's say, 4x squared plus x minus 26. Now we need to find the factors of this. You can either call it a function. In that case, we will be factorizing this thing. Now, obviously, you know the idea. The idea is very simple. You have to first find out one root, that 2 from hit and trial. So suppose I substitute 1 as x as 1. So this will be 1 plus 4 plus 1, that is 5 minus 26 will not give me a 0. So the first root x equals to 1 does not satisfy. Let's try that with x equals to 2. So this is 8. Okay, I can write it somewhere. You can remember this also, numbers. This is 4 4s are 16 minus 2 minus 26. Now if you pay attention, 8 and 2, 10 and 16, that is 26 minus 26 equals to 0. That means x equals to 2 satisfies. In other words, x minus 2 is a factor. Now you can use x minus 2 and do the long division method of, finding the quotient and then factorizing. But then there is a elegant way to do this thing through something called as a synthetic division. I will explain the synthetic division through that example only, so that we'll not find any problem. So the question that was given to us was x cube plus 4x squared plus x minus 26. We have already calculated that at f equals to 2, this is 0. So what I need to do is, I need to form a layout like this, and I'll just need to write the coefficient with the signs. So 1, you can write it like plus 4 minus plus 1, but then again you can omit the positive signs. 1 and 26. We will be dividing this number by 2 because 2 is a root. Okay, this 1 will come as it is, so this is going to be, this will come here as it is. 2 1s are 2, this is going to be 6. We will add. Okay, we are not subtracting, we are adding. 2 6s are 12. We are adding whatever is the sign, we are adding. This is 13. 2 into 13 is 26 positive. This is 0. Now this is your coefficient of the other quotient. In other words, this is as good as x minus 2 and x squared minus 6x plus 13. This term will always represent the coefficient of x squared, this term the coefficient of x, and this term the coefficient of, or rather the constant term. You have to remember the last term is the remainder, and that's why we call it a remainder theorem for synthetic division. If the remainder is 0, then you know for a fact that this expression is a factor of the cubic that was given to us. Now how do we factorize 13? So 13 is a, it's a prime, so you cannot factorize 13. So at this point, obviously you will have to use the quadratic formula to find out further roots. Okay, because it is in such a form that the mid split cannot be practiced. That is why I'll just leave it at this. So somebody asks you that what is the factor of this expression? The factor of this expression is this expression, which is x minus 2 into x square minus 6x plus 13. Okay, that's it. Thank you.